All right, we got a video here on number systems that we're looking at. We're gonna do some things there as we go with this. So what we want to do is I just want to go through some definitions first with you guys. This first definition is natural numbers. Natural numbers are all positive numbers is what we're looking for. So numbers like 1, 2, 3, 4, 5. So we're going to not have any fractions with that. We're just going to have positive values, so no negative values as well. So that is a natural number, all positive numbers. A whole number is really, again, no fractions, but it's also, and they're all going to be positive and 0. So we're going to have 0 and then 1, 2, 3, 4, 5, 6, blah, 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 blah. Keeps going with all these. Okay, so whole numbers, we're looking at that as well. Okay, so that's whole numbers there. We've got natural numbers, whole numbers, integers. We're now going to add in. So all of these you guys are going to see. We're going to add in numbers to these. So integers are going to add in the negative whole numbers as well. So this goes from like negative 4 to negative 3 to negative 2, negative 1. It includes 0. It includes 1. It includes 2, 3, so on and so forth. Okay. So we want the negative whole numbers and the positive whole numbers. Those are those integers. Rationals, again, they call these rationals because rational, what we've got here, our root word is a ratio here. So these are going to deal with anything that can be written as a fraction is a rational. So we're going to take our whole numbers, our natural numbers, and we're going to write them as fractions. So like if I had 2/3, that'd be a rational, or I could have 7/5. That would be a rational number as well. The other thing you got to keep an eye out for is if you have a decimal that ends, so like 0.5, obviously that can be written as a fraction. That's why this is called a rational. So really, if you see a decimal that ends, it doesn't stop, like you haven't rounded or anything, it just stops where it's at. That's a rational. And the other ones are the decimals that are repetitive. So like if I had like 2.33 repeating over and over again, that's 2 1/3, which again, that repeating makes that a fraction as well. So decimals that end can be written as fractions, and decimals that repeat can be written as fractions. The definition of a rational is anything that has a ratio with it. So fractions in that way. Okay? Technically speaking, guys, all integers are rationals because like 2 can be written as 4/2, right? But we don't classify it as a rational because we always classify it with whatever's the lowest it can be. Okay? So that's where you're going with that. Irrational is anything that cannot be written as a fraction, because ir means not in math, so anything that cannot be written as a fraction. So there's a couple things that go with that. Any decimal that just just keeps going and going and going goes in here. The other thing that we have is like square roots, and specifically square roots of not perfect squares. So like the square root of 5, because that won't simplify to that. Or we could have like the square root of like 2, or the square root of 20. These are all irrational numbers. If you were to type these in your calculator, they're going to give you some number that's like 0.8775, whatever. It's just going to keep going forever and ever. Okay, so that's why these are irrational. So anything that has a decimal that just keeps going that does not repeat, that's called an irrational. Or we have these radicals. This sign with the square root, these are called radicals, just so you know. You do need to be careful with this, though, because remember, if I have like the square root of 4, the square root of 4, when I simplify that, that's actually 2. So don't forget that that little bit as well. Okay? And if you, all these things on the left, they're what we call reals. So reals are all these others. So they're anything that's a natural number, a whole number, an integer, a rational, irrational. All those are what we call real numbers. Okay, and not real in the sense that they exist, but just real in the sense that that they're either an integer or a rational or irrational number. Okay. Imaginary values. Let's talk about imaginary values. And again, guys, I wish I could go back 10 time and like rename this, because again, don't think of these numbers as being like they're just an imagination, like your imaginary friend that you all have, okay? Or you had. I know somebody's got one still, but who knows? Anyway, imaginary in this sense is it's just a term of how we define it. We define an imaginary number that's taking anything that's the square root of a negative number. So like the square root of -2 or the square root of -4. Any of these values are what we call imaginaries. And we're not going to write them as the square root of -1. We're actually going to write this as I square root of 2. That's actually equivalent. These two are the exact same thing. To kind of have an idea of this, we define I as just being the square root of -1. Okay? So really the square root of 2, if I, over here to this side, if I have the square root of -2, I can actually rewrite that as the square root of -1 times the square root of +2, because you times those two together, and we're kind of undoing it. And so that's where I get the I square root of 2. Really what you need to understand is that imaginaries exist because we're taking the square root of a negative value. And so whenever you see this I is a number. It's not just a letter. It's a number. It's the square root of -1, and we can use that to simplify. The square root of -4 would simplify to 2I, because this would just be I square root of 2, because the square root of 4 is 2, and that's where you get the 2I from. The I comes from the negative value, the square root of -1, and then the square root of 4 is 2. If I had like the square root of -17, that does not simplify. This wants to write. That'd be good. That would simplify to I square root of 17. Maybe. Doesn't like to write the 7s very well. If I had like the square root of -9, that would be 3I. And the I comes from the square root of -1, and then the square root of 9 is just 3. And then the last type of number we have is a complex number. A complex number is a real plus or minus an imaginary. Okay? And so it's really just combining those two things together. So if I did like 2 plus or minus 3I, that is a complex number. And I say plus or minus, this is actually two of them. This would be 2 plus 3I and 2 minus 3I. I could separate them still. I could go like, hey, instead of this, I could write it as 2 plus 3I. That's a complex number. Okay, or I can change it. We can go -1 minus 4I. That would be a complex number as well. It's just whenever you take a real and imaginary, you can't combine those two. So you have to look at it from that sense right there. So, okay, so if I look back at this, what last thing I want you guys to be able to do is to kind of look at, to do some combining of these. So, for example, if I take, let's say I took 3 and I added it to 5, what number system does that go to? Well, if I simplify that, and again, I'm not simplifying and I'm not solving this, I'm just simplifying. This would be 8. Well, 8 would be a natural number. Okay? Let's see, if I had an integer, let's say I just had an integer of -2, and I wanted, let's say, adding that to let's say a rational number. So add 1/2, what does that leave me with? Well, when I add those two together, that's actually going to give me -1 and 1/2. So that's still a rational number. So you need to be able to kind of identify when you do an operation what happens. The ones you kind of need to be careful with, guys, is if I give you like 3, let's say plus the square root of 4, so a irrational and a whole number, You guys remember, this one you got to check and see if it simplifies. If it simplifies, this is just really 2, which simplifies to 5. And then in that case, we have a natural number, right? Whereas if I had like 3 plus the square root of 5, this doesn't simplify and I can't combine those. And then this would just be, when you add them together, you get a decimal, but we can leave it like this. This would be an irrational number. Okay? Here's how all those systems work, guys. I want you to think about this. I have my natural numbers. Okay, and they're all in this little bubble right here. Let's just say they're all here. They're all contained in this if I could write every single one of them. And then outside of that, I include everything of the natural. So my whole numbers are all the natural numbers and 0 as well. Let me do this. Let me write this in a different color here. So 0 is also included in here. So this has like, again, 1, 2, 3, but also the whole numbers has all those and this, okay? The next part out, and hopefully you guys are already talking about this is integers, which is going to include all my negative values, so like -3, -4, everything else that goes in there. The next ring around includes everything, and then adds onto that. These are called rational numbers. Oops. Let's actually do this. Let's go. Make sure we got our colors the right way. So rational numbers include everything inside, and it also includes any fractions, so like 2/3, or 0.5, so 1/2, or 0.33, so 1/3. Any of those are going to be included in there. Then we're going to include all of these numbers, and then add onto that, we're going to have, this is going to be called irrational. Okay? Actually, sorry, take that back. Whoa. Hold on. Don't want a circle there yet. I messed up on my circle, so excuse me for that. Give me 2 seconds here. We'll erase this. So irrationals, remember, rationals are not irrational, so we're actually, when we go to draw this, we're actually going to have a bubble here for irrational. Okay? Kind of like this. You guys look at this. See this little diagram here? You can see that. That might help you as well. Okay? And so this has all your irrationals, like the square root of like 3 and any decimal that doesn't repeat. And then this whole bubble is, remember, we call these real numbers. And reals are all everything in here and then everything right here. And then we've got this bubble that's on the outside, again right here, that is going to be involved. We're going to call this our imaginary numbers. This is going to have all our imaginary numbers. And that has like the square root of negative values, so like 2i and the square root of like -5, those type of things. And then our complex numbers, technically you're going to have everything here. So my complex, because remember complex is a real number plus an imaginary, and that contains everything. That's kind of what it looks like. Really what you need to do is if I give you a number, you need to be able to identify it by its lowest. So if I tell you like -5, I know -5 is rational and it's irrational, it's rational, but we're going to call it an integer because that's its smallest group that it's part of. For example, if I say like 3, I know 3 is also an integer. It can be written as a rational. It's a whole number, but it's a natural number, so we're going to call it a natural number at that point in time. And then the second thing you need to be able to do is if I do some arithmetic with these, what type of number do I get out from that? Okay, that's it. Math moment with Mommy. Adios.